Injuries in contact and motor sports are very common. Some of the worst injuries a player can sustain is to the neck and back. Across the course of their career, approximately 10 to 15% of all football players will sustain an injury to the neck and back. Even people wearing professional equipment have little protecting their neck and spine. That's why we created the ENPS, exovertebral nanotechnology protection system. High school sports injuries are something we encounter every day. We decided to create an improvement to sports uniforms to reduce the amount of these injuries happening.
Once we identified our main problem, we began to research a new solution.
In our research, we came across a research paper from the Vaughan Institute of Aeronautics and Technology. The research paper was about using a tube filled with non-Newtonian fluid known as oobleck to cover the neck of NASCAR drivers. It gave detailed information and tests about the effects of non-Newtonian fluids.
We then started the second half of the research, non-Newtonian fluid. We had questions about what it was and how to make it. Non-Newtonian fluids stiffen upon impact, disobeying Newton's law of viscosity.
Using this research as a platform, we developed our first design, an undershirt with tubes filled with non-Newtonian fluid attached to the neck and spine.
After we finished research of non-Newtonian fluids, we began the construction of our prototype of the ENPS, the exovertebral nanotechnology protection system. Before we started the actual construction of our prototype, we experimented with a common non-Newtonian fluid known as oobleck. This is a mixture of cornstarch and water that is a liquid until a shear force is applied, and then it transforms into a solid. This mixture exhibited the properties we were searching for, but over time separated into each of their components. Therefore, we switched to a military-grade, non-Newtonian mixture made out of polyethylene glycol and silica dioxide nanoparticles. For our first prototype, we used a polyester shirt and fortified the cloth with a shear thickening fluid in order to increase the durability and make it less susceptible to tearing. We then formed a brace that ran down the spine, which was 3 flexible PVC tubes full of our non-Newtonian mixture of polyethylene glycol and silica dioxide particles. The tubes remained flexible under normal circumstances, but when a force was applied, the tubes stiffened up. This will be applied to sports uniforms to prevent the head from traveling too far back and causing whiplash to the neck. Our team has worked hard to find some major improvements to the first prototype. We have capitalized upon some rather important revisions to our product since the original competition, including making our design machine washable and finding a more appropriate ratio of polyethylene glycol and silica dioxide nanoparticles. We are no longer treating the shirt with a shear thickening fluid in order to maintain its original condition even while being machine washable. Also, we have created a pouch in which the tubes filled with a mixture of polyethylene glycol and silica dioxide nanoparticles can be placed in, which can be then easily removed for washing. All these improvements have led us to creating a more consumer-friendly and overall higher quality product that can prevent whiplash while still being consumer-friendly and affordable.
Our business partner was Stoner Incorporated, located in Corryville, Pennsylvania.
At Stoner Incorporated, our group was able to coordinate with research and development engineer Quinn Hauser. Mr. Hauser was a very valuable resource in regards to both research and information, as well as allowing us to stir our non-Newtonian fluid. While we were there, we were also able to discuss the cost of our fluid, as well as use a formula to find the cost of mass production.
The final product of the ENPS is designed to lessen the severity of spinal injuries from contact sports and other activities.
The ENPS features a form-fitting shirt with a protective back brace, which fits into a special pouch sewn into the back of the shirt. The brace is composed of 3 flexible polyvinyl tubes, each filled with our mixture of polyethylene glycol and silica dioxide particles. The brace is designed to allow for deliberate, intentional movement of the back and spine, but to stiffen when acted on by a large force, deterring unwanted spinal movement. We hope that with further testing and development, the ENPS could become widely available to all athletes with significant risk of neck or spine injury.